Hi, Dan Kenning here. I wanted to talk to you tonight about magnetic fields and field vectors. Unlike some of the other students in the class who may be using compasses for their demonstration, I decided to take a little bit of a different take on this and talk to you about how these magnetic field polarity changes affect geology. What I have here is a piece of basalt. It's a dark colored igneous rock, which means it forms from molten material that has crystallized and solidified. And what I want to transition over here to show you is a map of magnetic field vectors on Earth. This should look familiar to anybody who has studied this. I'm going to go ahead and switch it over to a little bit of a different display, which shows the velocity of the particles. Every 1 to 3 million years, something crazy happens on Earth. The poles flip, they reverse themselves, and they do this. They start changing directions. That has some pretty interesting effects on this rock. The small iron crystals in these, as these cool, actually line up with Earth's magnetic field, and so they have a permanent magnetism stored in them. That's one of the ways we can determine a map like this, the age of the crust. For example, along the mid-ocean ridge, the youngest rocks are right in the center, and they get older as you go outwards. In this way, we can trace the movement of the continents over millions of years, and this is some of the best and direct evidence we have of the existence of Pangaea. This is actually not new information. It was discovered by oceanographers 70 or 80 years ago, and they named these magnetic anomalies in ocean crust zebra stripes because that's exactly what they look like. The magnetic properties flip every 1 to 3 million years, and there's a record of that stored in the iron-containing basalt rocks on the floor of the ocean. Hopefully this gives you a little bit of a geology history as well as some information on how geologists can chart the age of the crust and learn a little bit about where the continents were in the past based on magnetic polarity. Thanks, and have a good evening.